Hello everyone, welcome to this online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology, Hyderabad. So, as you all are aware, in this video lecture series, we are discussing about all the manufacturing processes. We started with the casting and then we discussed welding. Now, the third part of this course we are discussing, that is metal forming. In metal forming, bulk deformation processes like forging, rolling, extrusion, all we have already discussed in this video lecture series. Now, today we are going to take the sheet metal forming. So, in sheet metal forming, we will start with, in today's lecture, what is the meaning of this sheet metal, what is the meaning of this sheet metal forming. Then, of course, the very important process in this sheet metal forming is deep cup drawing that we are going to discuss in today's lecture. And then in that particularly we'll see how many different stages are there, means when we are doing this deep drawing, so at different stage what actually happens in that, means how compression is going to play their role, how tension is going to play their role, what will be the work of friction when it will be between the die and the punches. So all these things we are going to discuss in detail in this today's lecture. So we'll start with sheet metal forming. So what is the meaning of sheet metal forming? So already if you remember at the starting when we started this metal forming operation, so I told you in this we are not going to melt the material, means just like casting. In casting already we have seen, suppose I have to produce this stylus. So what I will have to do first, exactly of this material, suppose this is made up of aluminum. So what I will have to do, ingot aluminum I will have to take. That ingot aluminum, what I will do, I will first raise its temperature so that it will reach to its melting temperature. Once it will reach over there, I know it will be in molten state, means it will be in liquid state. Then what we'll do, predetermined dimension. Suppose I have to produce this shape exactly. So what I will do, I will prepare mold and then mold cavity exactly of this same shape and size with the help of pattern, and then I will pour over there. Once I will pour over there, I know after solidification it is going to exactly take the shape of that one. So what the important thing in this one is to convert the shape, means to change the dimension of a body. What we have to do, we have to liquefy or we have to melt a material, and then in a particular dimension cavity that we have already prepared, we have to pour over there. In welding we saw, if we have to prepare or manufacture assembly or we have to prepare, we'll have to join two or more than two materials together. But in the case of forming, we are not going to melt the material, we are not going to actually weld the material. What actually we are doing, simply we are applying forces. Okay, now suppose we have to increase the length, we have already discussed this one, that if we have to increase the length of this stylus, what we'll do, we'll simply apply the force, tensile forces. Okay, now so its length will increase, and obviously if length will increase, we know volume of this stylus is going to be constant, so obviously cross sectional area will be reduced. Okay, so similarly if I have to increase the cross sectional area, then of course I will have to apply from both sides compressive forces. So what will happen, its length will decrease but its area of cross section will increase. Okay, so what actually we are doing in this metal forming, we have already discussed that only we are applying the forces, maybe one force or it may be combination of two or more than two forces to change the shape and size. So far in bulk deformation, what we discussed in rolling, the thickness of the material that we were using to change its dimension or its shape was more. More means generally more than 5 mm. So that is known as sheet metal, means bulk deformation. But now we are going to discuss about the sheet deformation, means the thickness of the material that we are going to work on, that we are going to change the shape and size will be of less as compared to that one. That's why this is sheet metal. So what is the meaning of this one? Here also there will be plastic deformation. Of course, plastic deformation means it will be a permanent deformation. And obviously, if I'm telling permanent deformation, so it's obvious that whatever the load or the force that we are applying on the specimen that we are going to change, obviously the force or the load will be more if we will compare with the yield strength of the material. So it is a severe plastic deformation. So what happens when the forces are being applied, it will be changed in a different dimension or different shape according to the die or the punch that we have provided. So we can see here it simply involves plastic deformation of sheet metal. Many examples are there. We will discuss today deep drawing in detail. So deep drawing, cutting is there. If shearing process is there, it's nothing but the cutting process. Cutting will be there. Bending will be there. Suppose this stylus I have to bend in U shape. What will I do? I will have to apply force perpendicularly on its axis, and then I have to support from both sides. So what will happen? Once I will apply force from here, it will take the shape of U. If I have to produce a V shape of this one, this is stylus, obviously my die will be of a V shape. We can see here. Okay, so simply what is happening here, we are applying the forces, there is severe plastic deformation, and once it will be completely deformed either at room temperature or at a high temperature, that is in hot working, whatever the shape of the die will be, definitely it's going to take the shape, and whatever the shape of the die is, that intentionally is provided so that the product finally that we are going to get will have that particular impression or the shape. Okay, stretch forming is also there, stretching is there, stamping, there are many sheet metal processes are there. Okay, so one by one, of course, we'll discuss in this. So we can see here, that's a very important thing. This is the blank or the workpiece that we are going to work on. Means this is the workpiece that we are going to change its dimension. So this is kept on a die, and this die is having this V shape. Okay, and our punch, this is the punch. Punch means simply through which we are going to apply the force. So we can see here this is also having V shape. So what will happen once it will come and strike this one? So this will start to deform, and it once it will start to deform, it will go inside this die cavity. What this V shape we have given. Okay, now, and after some time, after one deformation will be there, obviously it will start to flow, and finally it will take the shape of this V. So finally this rod or the blank will be in the V shape. So we can see here. So this is bending operation. This is one of the sheet metal. If we are cutting the sample, two pieces we are cutting, so we can see here we have this pressure pad kept over there, and obviously from the top we are applying force so that it will not be removed from its place. Not only that one, also it will keep this blank intact at its position. Okay, and then we have the die, and from the side we are applying the force through the punch. So this is the punch through which we are applying the forces. So what will happen once we will apply this one? This will be bended from the side. We can see here this will be bended from the side. So depending upon what is the position we are keeping of our die, and obviously how we are going to apply the force through the punch, material will take the shape. Now, so we'll start this first process. This is a cop deep drawing, and we'll try to see what actually happens in detail in this process. So this is a sheet metal. Already we have discussed. This is a sheet metal operation in which sheet is placed over the die opening. Okay, so this die opening is there. Already we have seen in bending. This die opening is there. On the top of that, we have to place the workpiece of the blank that we are going to change its shape and dimension. So, and then it is pushed by the punch into the opening. So, whatever the die is there, that particular shape we want, okay, now on that, on the top of that, we have to place the blank or the workpiece. On that, through the punch, we are going to apply the force. And once that force will be sufficient means it will go beyond the yield strength of the material will start to flow, and once it will start to flow, it is going to take the shape of that particular die, and once it will take the fully the shape of that die, then our product or whatever our specimen is, it will be in the final form that we want. So here also in the drawing we can see many technical terms are there. One by one we'll see. The sheet is held flat on the die surface by using a blank holder. So this is actually blank holder. This is our workpiece on which we are going to work on. Means this is the workpiece on which we are going to apply the force, and we will force it to flow inside this die. Okay, na? This die cavity. and obviously once it will be forced to flow in this one, it will take the shape of the die. So what is happening, this is the punch through which we are applying the force. In this, many technical terms are there. C is the clearance, okay, the gap between these two. You can see here, this is the die and this is the blank. So this gap provided here and this gap provided here, here also you can see this, this is actually C, this is the clearance is being provided over there. So this is the clearance, this is the blank diameter, dB is the blank diameter. Blank diameter means this blank, this workpiece is there, this is in this is the shape, this is the blank, so this is the blank diameter. Then you have dP, this punch diameter, so this is the dP, that punch, the cylindrical punch we are applying, okay na? So this diameter that we are applying force through, and this is the diameter of the punch. Then we have radius, RD, we can see here, this is the radius, means this die is there, this is the radius, this die is there, and what is the radius of this one, this is actually RD, okay, die corner radius. Then we have punch corner radius. Similarly, we can see here punch, here is the punch. So whatever this radius is, this is known as punch radius. So many technical terms are there. Then we have a drying force, means what force we are applying to change that blank in that particular shape, that is known as drying force. And of course we have blank holding force, this is known as, this is given by Fh. So we can see here, this is Fs is this blank holding force. So this is the blank, sorry, this is the blank through which we are holding our workpiece, this workpiece. So suppose this is the workpiece, on that we have a blank holder, here also blank holder. So through that we are applying the force so that it will be intact at its position and it will not move, okay. So this is the blank, so from the top we are applying the force. This is the drying force, and very important to understand, this is mathematically given as, this drying force is mathematically given as shear stress of the material. Suppose any material we are using in the form of sheet, what is the shear strength of that material into what is the perimeter of that, whether you are creating a hole over there, we are punching, or whatever the dimension that we are going to generate over there. So what is the perimeter of that one into what is the thickness of the blank, means what is the thickness of the material that we are going to convert in a particular shape. So this is given as, this blank force or this punch force is given as shear stress of the material, that's the tau s, into what is the perimeter of that material and then what is the thickness of that material. Now technically actually this taken as, means this is not fixed, it actually varies according to the material, but this clearance is generally defined to equal more than 10% of the thickness, that is T of the material that we are going to deform, okay. So next is different stages, as I said, different stages are there, and at every stage in deep drawing what happens, that one by one we are going to discuss. So first we'll take step 1. As the punch pushes the sheet, it's subjected to a bending operation. We can see here, diagram is also there. As it pushes, we can see here there will be bending, okay, of the blank. So there will be bending, that's what has been written here. As the punch pushes the sheet, it is subjected to a bending operation. The bending of sheet occurs over all the punch corner and die corner. We can see here in the diagram, it will be clear. This is die corner, sorry, die corner, and this is punch corner. So you can see once we are pushing from the top, means applying the force over there on the blank. So what is happening? There will be bending at the corner at both sides. That's what has been written here. The outside perimeter of the blank moves slightly inwards towards the center. Okay. In the second stage, in this stage, the sheet region that was bent over the die corner will be strengthened. You can see here. Once it is bended, so after that, what it will be? It will be strengthened. You can see here, when it was bended at these corners, now it is completely strengthened. Means it is now straight over there. So that's what happens in the second stage, in the clearance region at this stage. So it will become cup wall region. Okay, na? In order to compensate the presence of sheet in cup wall, more metal will be pulled from the sheet edge. That is, the more metal moves into the die opening. Okay. In third stage, of course, friction. Where will be the friction? We already know whenever there will be two surfaces in contact and one is moving relative to the other, definitely there will be friction over there. So what is happening here? Our blank is moving because we are applying force to the punch. So what will be the friction? The part wherever it is in contact, obviously there will be friction. So here it is in contact, we can see here it is in contact. So what will here it is in contact? Wherever it will be in contact, because of that there will be friction. And if friction is there, no need to tell, it will create problem in material flow. Okay, so many um, things people use to different kind of lubricants people generally use to use over there to remove or eradicate the effect of the friction over there. So what happens here? Friction between the sheet and the die, blank holder surfaces restricts the movement of the sheet into the place. It's a common sense. Friction will oppose the free movement of the blank. Okay, the blank holding force also influences the movement. Obviously, it will be that is the reason it is kept over there. If we are using this blank holder, so definitely it is going to influence the material flow because we are applying the force, and here also we are pressing the blank or the material over there through that the blank holder. So obviously it is going to influence the material flow in the die. Lubricants or drying compounds are generally used to reduce the frictional forces. Okay, other than friction force, compression occurs at the edge. We can see through the diagram here. Compression occurs at the edge. That's what is being written here at the seat. Since the perimeter is reduced, the seat is squeezed in the opening. Okay, and because volume remains the constant with the reduction in the perimeter, thickening occurs at the edge. That is very, very important. And finally, the final cup part will have some thickening in the wall thickness. This wall thickness, some thickening will be there. So this diagram, all the stages clearly has been shown here. We can see this is the punch. We have already discussed also. This is the punch. Okay, this is our blank holder. Through that we are holding our blank. This is the workpiece that we are going to transform into a cup shape that you can see finally here it is. Okay, and this is the die. These two dies are there. It is fixed at its position. Okay, in first stage, as we have already discussed, at the die opening, see, and this one and this punch edges, there will be bending of the sheet. Okay, and then after that, once this second stage bending will be over, then straightening will be there of that sheet in the third stage. And fourth stage, what will happen at the edge, there will be compression and thickening of the flange, will be compression and thickening of the flange, and finally it will be in the form of cup, but at the edges there will be thickening in the cup. This, that is the wall, there will be thickening over there, and finally this cup shape will be generated. So that's all for today's lecture. In next we'll take few numericals and we'll try to complete this course in next lecture. Thank you.